Good morning. Today we're going to be taking a look at a brand new unit. So we are in Chapter 9, and we're going to be taking a look at quadratic and higher degree equations and functions. But today we're going to be looking mostly at a method called completing the square. And we're going to be looking at some examples first that will help us once we know how to complete the square. But we're going to start with example 1 where we have the quantity x plus 1 squared equal to 12. And we want to solve for the value of x. So when we want to start solving for x, we're going to have to isolate it. And one of the things that we notice here is that x is not by itself, right? It's a quantity, it's a binomial, and that binomial is squared. So before we can start doing anything like -1 on both sides or anything like that, we have to follow order of operations, and we have to basically square root first, right? We want to get rid of the exponent, all right? So what we're going to do is we're going to take the square root of both sides, all right? And when we take the square root of both sides, a square root of a square, those are inverses. They undo each other, right? It's just like plus or addition and subtraction are inverses of each other. Well, a square root and a square, those are inverses of each other. So what I end up getting is x plus 1. And on the right side, I have to be careful because anytime I take a square root, there are two possible answers, right? If you think about the square root of 9, technically, we can have 3 or -3 because 3 times 3 is 9, but -3 times -3 is also 9. So there are two possible answers. So I'm going to write this as plus or minus radical 12. All right, then I need to isolate my x, so I'm going to do -1 on both sides. And we can see that on the right side, we do not have like terms, right? This is an integer or a constant, and this is a radical. What we're going to do, since we can't combine them, we have to write both terms. And what we want to do is we want to write the constant first. So we're going to do -1 plus or minus radical 12. All right, and I can simplify radical 12, right? That is 4 times 3, and I can take the square root of 4. So let me just write it out like this. That's 4 times 3, and the square root of 4 is 2, and then I have radical 3 left over on the inside. Still, these two are not like terms, right? This is a radical altogether. We can't separate that 2 from that radical 3. And so this is our final answer, and I just want to show you this actually has two, or represents two answers, all right? So because of the plus minus, what we actually have is one of our answers for x, so that's a notation there, a sub 1. We have -1 plus 2 radical 3, and if you plug that into the calculator, you get some decimal. And our second answer is the other option, which is -1, but now minus 2 radical 3. So you could also write your answers in this way, and in this way it's really clear that there are two different answers. But the shorthand way of writing it is using this plus or minus symbol. All right, so when we take a look at a quadratic, which is what we're dealing with here, and I know it's a quadratic because the exponent is 2, that exponent actually tells us how many answers we're going to have. So because the exponent is 2, I have 2 answers. All right, so we're going to take a look at another example, and it's going to be pretty similar with one exception. So we are going to be solving 2x minus 5 squared equals -16. So maybe you already realized that there's something a little bit different about this. All right, so let's go ahead and just kind of start the same way that we did previously. So what we're going to do is we're going to get rid of that square first. So we're going to square root both sides. All right, a square root of a square cancels out. So what I have left is 2x minus 5 is equal to, and remember that anytime you take the square root of a radical, you're going to have plus or minus. All right, now you might already be thinking, well, there's a negative in there. That seems kind of odd, but you guys know how imaginary numbers work now, and so we're going to be able to work with that. All right, so at this point, we could actually just simplify this right side. So I'm going to bring down the left side. All right, and the square root of -16, well, the square root of 16 is 4, and the square root of technically a negative 1 that's in here. All right, let me just kind of expand this a little bit. This is technically negative 1 times 16 inside of that radical. So the square root of negative 1 is I, and the square root of 16 is 4, so that's 4I. All right. If you don't really remember imaginary numbers too much, you might want to go back to the lessons from last week and just kind of refresh yourself a little bit on that. All right, so let's go ahead and start solving for x. Now it's just some basic algebra. We're going to do plus 5 on both sides. And the question here is, can we combine these? Are these like terms? Well, this is an imaginary number and this is a real number, so they are not like each other. So we're going to have to write them separately. The real number always goes first. Remember that from last week. So we have 5, right? Positive 5. I don't need to write plus in front of it, but I do need to write plus, minus, and then the 4i. All right? These cannot combine. This is not 9i. The last thing I need to do is I need to divide both sides by 2 so I can get x completely by itself. So I have an answer of 5 plus 4i, plus or minus 4i all over 2. If 2 could divide into both of these coefficients, 5 and 4, I would do that. But 2 can't divide evenly into 5. 2 can divide evenly into 4. But unless you can do it to all of the coefficients in the numerator, you can't simplify any further. So this right here is our final answer. And remember that this is actually the representation of 2 different answers, right? So this actually represents 5 plus 4i over 2, and also represents the second answer, which is 5 minus 4i over 2. So you can see that this quadratic does have 2 answers. All right, you do not need to write it out like this. You can write it shorthand using the plus minus. It's completely up to you, whatever your preference is.